Nitrogen monoxide reaction with chlorine according to the following equation. 2NO gas plus Cl2 gas producing 2NOCl gas. The following initial rates of reactions have been observed for certain reactant concentrations according to this table. A. Determine the rate equation from the given data. Rate expressions take the general form of rate equals K times concentration of A to the power of A times concentration of B to the power of B. First, I would like to label the free experiment from 1 to 3. So for each experiment, they use different concentrations of the reactant and they record different initial rates of the reaction. Now let's focus on part A. Part A asks us to find the exponent A and B for the rate expression. So our strategy is going to be to find A and B. We're going to take a ratio of two different initial rates from two experiments. So let's say to find A, for example, I'm going to take rate of experiment 2 divided by rate of experiment 1. First, let's expand rate 2, for example. That's going to be K times concentration of NO in experiment 2 to the power of A times concentration of Cl2 in experiment 2 to the power of B. Now, let's also expand rate 1. Rate 1 is going to be K times concentration of NO in experiment 1 to the power of A times concentration of Cl2 in experiment 1 to the power of B. Next, let's substituting in the numbers in. On top, that's going to be K times 0.90 to the power of A times 0.45 to the power of B. On the bottom, that's going to be K times 0.45 to the power of A times 0.45 to the power of B. So here we see that the K and the 0.45 to the power of B appears on both top and bottom of the fraction, meaning that we can cross it out. This is why we pick experiment 1 and 2 when finding A, because the concentration of Cl2 in experiment 1 and 2 is exactly the same, 0.45. So that way it can be neatly canceled out so that you can focus on finding exponent A instead of worrying about both exponent A and B. Now moving on, after you cancel out, you will end up with 0.90 to the power of A divided by 0.45 to the power of A. And we can also write it as 0.90 over 0.45, all of them to the power of A. Now, let's go back and substituting in the numbers for rate 2 and rate 1. That's going to be 3.32 over 0.831. And that equals to 0.90 divided by 0.45, all of that to the power of A. So now calculating the ratio of rate 2 over rate 1, we're going to get an answer of 3.99. And 0.90 over 0.45, that's going to give 2 to the power of A. So here we can say that 3.99 is roughly 4, and therefore we can derive that A is equal to 2. That way 2 to the power of 2 can equals to 4. So this is how we found A. So A is equal to 2, and now we can write the rate equation as rate equals K times concentration of NO to the power of 2 times concentration of Cl2 to the power of B. Now, let's move on and find B. So using the similar strategy as when we find A, now we're gonna choose two experiments in which the concentration of NO is exactly the same so that we can cancel out the concentration of NO and focus on finding B. That means we're going to take rate 3 divided by rate 2. Expanding on rate 3, we're going to have K times concentration of NO in experiment 3 to the power of 2 times concentration of Cl2 in experiment 3 to the power of B. Expanding on rate 2, we'll have K times concentration of NO in experiment 2 to the power of 2 times concentration of Cl2 in experiment 2 to the power of B. Next, let's substituting in the numbers. We're going to have K times 0.90 to the power of 2 times 0.90 to the power of B. And on the bottom, we have K times 0.90 to the power of 2 times 0.45 to the power of B. Here, we see that the K and the 0.90 to the power of 2 appears on both top and bottom of the fraction, and therefore we can cancel it out to end up with 0.90 to the power of B over 0.45 to the power of B. And this can be rewrite as 0.90 over 0.45, all of that to the power of B. Now, let's go back and substituting in the numbers for rate 3 and rate 2. That's going to be 6.65 over 3.32, and that equals to 0.90 over 0.45, all of that to the power of B. So calculating the ratio of rate 3 over rate 2, we can end up with 2.00, and calculating 0.90 over 0.45, we're going to have 2 to the power of B. From there, we can derive that B equals to 1, so that 2 to the power of 1 equals to 2.00. So now that we found B equals to 1, our rate expression is going to be rate equals K times concentration of NO to the power of 2 times concentration of Cl2 to the power of 1, which we can omit. So this is the answer to part A. Let's move on to part B. Part B asks us to determine the rate constant using data from the first row of the table. So that means we're going to have to find K. So to find K, let's look back at the rate equation that we derived in part 1. The rate equation for this reaction is rate equals K times concentration of NO to the power of 2 times concentration of Cl2 to the power of 1. If we rearrange this, we'll have K equals rate divided by concentration of NO to the power of 2 times concentration of Cl2. And here they ask us to use data from first row, so we're going to use rate of experiment 1 divided by concentration of NO in experiment 1 to the power of 2 times concentration of Cl2 in experiment 1. Now let's substituting numbers in. That's going to be 0.831 over 0.45 to the power of 2 times 0.45. And that's going to give us a result of 9.12. That is going to be the rate constant for this reaction, according to the data from the first row of the table. Thank you for watching. Please like and subscribe if you like our content.